This is a study guide to the problems that deal with solving polynomial equations and rational equations. So number one, you're asked to solve this linear equation. Notice this is a linear equation. So if you look at all the exponents of the variables, you'll see x to the first, x to the first, x to the first, and so on. So that's a linear equation. It is considered a polynomial equation, but in this case, though, this polynomial equation is a linear equation. Now, one of the things you want to notice is that you have some parentheses here, and all these parentheses are being raised at, well, the expressions that's inside the parentheses are being raised to the first power. See, x minus 4 to the first, x plus 2 to the first, and so since that's the case, the first thing you want to do to solve this linear equation is to use the distributive property in each of those cases. And so when I look on the left-hand side, I see 2 times 3x minus 1. So if I multiply every term that's inside this parentheses by 2, because that's what this says, 2 times, I get 2 times 3x is 6x, and then 2 times a negative 1 is a negative 2. Over here, I'm going to go ahead and distribute a negative 3. So negative 3 times x, because remember, subtracting a negative 3 is the same thing as saying adding a negative 3. So I'm going to distribute the negative 3, so I'm going to multiply every term that's inside this parentheses by negative 3. So I get negative 3 times x is a negative 3x, and then a negative 3 times a negative 4 is a positive 12, and then plus 6 equal. All right, now on this side, you got to be careful. Some students, when they see this, they want to say 7 plus 3 first, and they'll get 10, and then they'll distribute the 10. But mathematically, that's not correct. So remember, the order of operations says I have to do multiplication first before I do addition. So I have a multiplication here, so I have to use the distributive property first. So don't say 7 plus 3 is 10 and then distribute the 10, because then all this is going to be incorrect. All right, so when I distribute the 3, I'm going to get 7 plus, and then 3 times x is 3x, and then 3 times 2 is 6. All right, so the first thing I did was to use the distributive property. Now what you want to do next is to combine like terms. So when I combine like terms, on the left-hand side, I have 6x minus 3x is 3x. So I'm going to say 3x here. Then I have my constants. So I have a negative 2, and a positive 12, and a positive 6. So negative 2 and 12, and a positive 12 is 10, and then 10 plus 6 is 16. So I get 3x plus 16 equal, and then over here, I get 7 plus 6, which is 13, so I get 3x plus 13. All right, now, I want you to notice that when I bring all the variables one side, constants to the other, I get subtract 3x from both sides. And so I get 3x minus 3x is 0. And so I get, see, this is 0. 0 plus 16 is 16. Equal. And over here, 3x minus 3x is 0. And then 0 plus 13 is 13. So notice, though, that the variables go away, right? There is no variable left in this statement. But what I want you to notice, though, is that since there's no variable left in the statement, you notice this statement is a false statement. 16 is never equal to 13. So what that means is that in terms of the solution to this original equation, there is no solution. So you have to say no solution. All right? Okay, so let's look at this example. I'm going to put this as 1 star. All right, so we're going to look at another linear equation. And so let's say I had negative 3 times 4x minus 1 plus 2 times, and let's say this is 2 minus 5x equal 8x plus 1. Okay? All right, so we're going to go ahead. Again, I have this polynomial equation, which happens to be a linear equation. And if I use a distributive property, because and also remember, I can use a distributive property in each of those cases here because that expression is being raised to the first power in both cases. So I can use a distributive property. And so I get negative 3 times 4x is a negative 12x. A negative 3 times a negative 1 is a positive 3. And then 2 times 2 is 4. and then 2 times a negative 5x is a negative 10x equal 8x plus 1. All right, combining like terms, I get negative 12x, and a negative 10x is a negative 22x. 3 plus 4 is 7, so on the left-hand side, I get negative 22x plus 7 equal, and then on the right-hand side, there are no like terms, so I'm just going to rewrite that expression. Now I'm going to go ahead and bring all the variables to one side, constants to the other, since this is a linear equation. So I'm going to subtract 8x from both sides, just like this. Notice what you do to one side, you must do to the other. So that has to be shown. Subtract 8x, you must say subtract 8x. Otherwise, mathematically, what you have is not a correct mathematical statement. Combining like terms, negative 22x and a negative 8x is a negative 30x plus 7 equal 8x and a negative 8x is 0. Those are opposites. So when you add two terms that are opposites, you get 0. 0 plus 1 is 1. And then subtract 7 from both sides. Notice what I do to one side, I do to the other to make it mathematically correct. Negative 30x, this is 0, equal 1 and a negative 7 is a negative 6. And then remember, you got to get x by itself. So we're now multiplying I'm multiplying x by negative 30, so that's my coefficient. Let me go ahead and rewrite this over. And so if I divide both sides by negative 30, by the coefficient, and then reduce, negative 30 divided by negative 30 is 1. 1 times x is x. And then you need to remember that a negative divided by negative is a positive, and 6/30ths I can reduce. That is 1/5. All right, and leave it as a fraction. Just make sure it's reduced. Don't write as a decimal unless you're told to do so, because some of you, if this were, see, 1/5 is a terminating decimal. But if it was not, and you don't, so if it's not a terminating decimal, some of you will round off, and what you have as an estimation is not the same as the exact answer. So in other words, what I'm trying to say is this. So for example, let's use the easy fraction 1/3. So 1/3, some of you are saying that that is equal to 0.33. Well, that's not true. Okay, that's not true. 1/3 does not equal 0.33. 1/3 is approximately equal to 0.33. So some of you are doing that. So to be on the safe side, don't approximate unless you're told to do so. All right, so be careful. Now, basically, just remember that 1/3. Remember that's that repeating decimal. So some of you will write it like this, but still don't write any decimals unless you're told to approximate or to write as a decimal. All right, so that's number one. All right, so number one, we had no solution here, and then 1 star. I just gave you another problem where we actually did have a solution. All right, so let's get to number two. So number two, you have this situation. So number two, we have this linear equation that looks like this: 2x minus 1 divided by 3 minus, and then you have this other fraction, this rational expression for 3x plus 4x divided by 6 equal, and then that's going to be 2x plus 3 divided by 2. All right. Now this is a linear equation. All right, so that's a linear equation. So one thing that makes this a linear equation, just like these right here, these were linear equations. The fact that the denominator is numbers, numerical expressions. There are no variables in the denominator. And then in the numerator, if you look at the variables, those are all x to the first, x to the first, x to the first. All right, so that's a linear equation. We can still consider this a rational equation even though there are no variables in the denominator. But this is linear. You consider this as a rational equation because you see fractions, right? So a rational equation. Now the way you want to do this though is you want to clear those denominators. You want to get that 3, that 6, and that 2 out of that denominator. And so when you have a rational equation or a linear equation with fractions, one of the things you want to do is to multiply both sides by the least common denominator. And so multiplying both sides by the least common denominator will clear those fractions. But again, as you go through the process, you have to make sure that your statements are mathematically correct. You have to learn how to write correct mathematical statements. So the least common denominator of 3, 6, and 2, so meaning the smallest number, always use the least. The least makes things so much easier for you. The smallest number that 3, 6, and 2 go into evenly is 6. So 3 goes into 6 2 times, 6 goes into 6 one time, 2 goes into 6 3 times. So my least common denominator is 6. Now what you're going to do next is you're going to multiply both sides by that least common denominator. Now I want you to notice that on the left-hand side there are two fractions here, two rational expressions. So we're going to put that in brackets, just like this. So I'm just going to go ahead and rewrite this equation, but I'm going to go ahead and put the left-hand side in brackets. And on the other side, since that's just one fraction, one rational expression, I'll just go ahead and leave it putting it without any brackets. All right, so now we're going to multiply both sides by 6. So times 6, just like that. All right, now, just like we did in the previous problem, see right here, we use the distributive property. So I have this expression that's being raised to the first power. So to get rid of that parentheses, I'm going to go ahead and use the distributive property. Same thing here. I have this expression here, right here, that's being raised to the first power. So mathematically, I can use the distributive property. So I get 6 times 2x minus 1 divided by 3 minus 6 times 3 plus 4x divided by 6 equal, and then 2x plus 3, that's an x here, divided by 2 times 6. All right, so now the next step is to reduce. So remember the whole point of multiplying both sides by the least common denominator is to get these denominators down here, these denominators, to be factors of 1. That's the whole point, to get those denominators to be factors of 1. And so you'll notice when I reduce, see 6, again 6 divided by, if you extend this division symbol right here, 6 divided by 3, so you can reduce. 3 into 3 is 1 time, 3 into 6 is 2. Over here, 6 into 6 is 1, 6 into 6 is 1. It's a good idea. Make sure, it's not a good idea, you need to, when you reduce, put those as factors of 1s. And then 2 into 2 is 1, 2 into 6 is 3. Okay, so now notice, again, the whole point of multiplying both sides by the least common denominator is to get 1s in those denominators so you no longer have fractions to deal with. Alright, so I have 2 times 2x minus 1. So notice that all of these terms here, 2x minus 1, both of those terms have to be multiplied by 2. So we need to put that in parentheses. 2 times 2x minus 1. Minus, now be careful here. So let's think of this part just like we did here. So all of these terms that's in this numerator right here has to be multiplied by negative 1. So make sure you write it as negative 1 times 3 plus 4x. Take the time and do this. Otherwise, if you don't put that parentheses here, it's going to be mathematically incorrect. Equal, and then 3 times 2x plus 3. So remember, multiplication is commutative. The order in which you multiply does not matter. So 3 times 2x plus 3. All right, and so now this looks just like we did number 1. So let's go ahead and use the distributive property. So I'm going to distribute both. I'm going to distribute 2 inside this parentheses. Over here, I'm going to multiply both of those terms by negative 1. And then over here, I'm going to multiply both of those terms by 3. So I get 2 times 2x is 4x. 2 times negative 1 is a negative 2. Negative 1 times 3 is a negative 3. Negative 1 times 4x is a negative 4x. Equal 3 times 2x is 6x. And then 3 times 3 is 9. Okay? Combining like terms, I have 4x and a negative 4x is 0. Y'all agree? So those add up to be 0. And so my constant, though, negative 2 and negative 3, that's a negative 5. So this side here just ends up being negative 5. Equal 6x plus 9. All right, now bring all the variables one side, constant the other. So I'll notice that the variable term is already on one side by itself. There is no variable term on this side. I just see a constant. So I'm going to subtract 9 from both sides. And so negative 5 and a negative 9 is a negative 14 equal 6x. This is 0. All right, to get x by itself, I'm going to go ahead and rewrite this over. So to get x by itself, I'm going to divide both sides by 6. And then we'll reduce. 6 divided by 6 is 1, so I get 1 times x is x equal. And then reducing this, so they're both divisible by 2, so I get negative 7/3. Now, again, don't write this as a decimal because it doesn't terminate. So leave it as a improper fraction, or if you want to, you could write as a mixed number. So you get x equal negative 2 and 1/3. Okay? All right, but don't write as a decimal unless you're told to approximate. All right, so that was number 2. Okay, let's look at number 3. Number 3, we do have a rational equation, and so notice number 3 looks like this. So here's number 3. We have 3x minus 2 divided by x squared plus 2x minus 15, and then subtract 6 divided by x minus 3 equal 4 divided by x plus 5. So this is a rational equation. It is not linear because I have variables in the denominator, so that's not a linear equation. It is, we do consider this, though, a rational equation. Now, just like we did in number 2, what you want to do is find the least common denominator. So you want to clear those fractions. So the way you're told to do this is to, first of all, clear the fractions. All right, so to clear the fractions, I've got to find the least common denominator. And to find the least common denominator, notice I have variable expressions. It's not as easy as number 2, in which case I had numerical expressions in my denominator. That was easy to determine the least common denominator. Here it's not. All right, so you have to remember, though, if I'm going to find the least common denominator, I have to notice, first of all, that this is a quadratic expression, x squared, a quadratic expression. These are linear expressions, and so you want to try and factor this quadratic expression. Usually, in most of our cases, when you factor this quadratic equation, the factors you put here, the linear factors you put here, will be these factors you see here. All right. Most of the time that'll be the case, but not always true. All right. So if you do what I'm about to do, then you need to check it, right? So you're probably going to say, well, I can factor x squared plus 2x minus 15 as x minus 3 times x plus 5. All right, well, you need to check that because that may not be true. So let's go ahead and check this. So let's check to see if x minus 3 times x plus 5 is equal to x squared plus 2x minus 15. So we're going ahead and use the FOIL method, F-O-I-L. So remember FOIL. And so first times first, so x times x is x squared. O is the outer, so if I look at the outer, x times 5 is 5x. I is inner, so if you look at the inside terms, negative 3 times x is a negative 3x. And then L is the last terms of each binomial. So the last terms, negative 3 times 5, is a negative 15. When I combine like terms, see those linear terms here, I get x squared, 5x minus 3x is 2x, and then minus 15, which is what we wanted. All right? Okay, so now, once we find the least common denominator, once you factor, we have to find the least common denominator. So your least common denominator must include every factor that you see. So I see a factor of x minus 3, so I must have it. I see my next one is a factor of x plus 5, so that must be part of my least common denominator. Now remember, the least common denominator is a product of your factors, so don't put a comma here, it's a product. The next factor I see is an x minus 3, but I already have it. So don't put it again, don't put another x minus 3, because then it's no longer the least, and so that would make it much more difficult to solve. All right, and then my next factor is x plus 5, which I already have. So my least common denominator is just the product of x minus 3, and x plus 5. Now the other thing you wanted to do is to find the restriction. So remember, when you talk about a rational expression, so you see I have three rational expressions here. So when you talk about a rational expression, you can never divide by 0. So you just have to determine what values of x will make each of those denominators 0, right? So if you look at this first factor here, x minus 3, I'm going to go ahead and do this. So x minus 3, I need to determine where's that 0. Well, that's a linear equation. That's easy to determine. So x minus 3 is equal to 0 when x is 3, right? And so then my restriction is that x cannot equal 3. That's one of them. The next factor I see is x plus 5. Remember, that's in my denominator, so I can never divide by 0. So to determine the restrictions, you just look at these denominators. So my next factor is x plus 5. So where's that equal to 0? Well, x plus 5 is equal to 0 when x equals negative 5. So there's my other restriction. Then my next denominator is x minus 3, which I already took care of. That's the restriction 3. And then x plus 5, the restriction is negative 5. Okay? So those are your restrictions. So basically, if you solve this, do all this work, and you got x to be, let's say, 3 is a restriction, you would say no solution. The same thing if you did all this work and you got x to be negative 5, you would say no solution because negative 5 makes this denominator 0 and also makes this denominator 0. All right, so you can never divide by 0. It's undefined. All right, so we found the least common denominator. Now we're going to do it just like we did in number 2. We're going to multiply both sides by the least common denominator. Now remember, on your test and on the worksheets, this process is what I want to see. So don't do it any other way. If you do it another way, you're not going to get full credit. So the way I'm doing this is the way I want you to do it on your test or worksheet. Okay, so we're going to multiply both sides by the least common denominator. Notice I have two fractions here, two rational expressions, put that in parentheses. And when you rewrite it, rewrite it, make sure you put it in factored form. So don't write it as x squared plus 2x minus 15. Leave it like this because that's going to be important because this part here is going to be your least common denominator. So it'll make things a lot easier for you. So in other words, write it as x minus 3 times x plus 5 minus 6 divided by x minus 3. Put that in bracket, equal, and then 4 divided by x plus 5. All right, so all I did was rewrote the original equation and just put the left-hand side in brackets since there are two rational expressions. Now I'm going to multiply both sides by the least common denominator just like this. So x minus 3 times x plus 5, and then x minus 3 times x plus 5. Okay, so what you do to one side, you must do to the other. Mathematically, that must be shown. Now I'm going to go ahead and distribute. And so I get the least common denominator, x minus 3 times x plus 5 times that first rational expression, 3x minus 2 divided by x minus 3 times x plus 5, minus, and then the least common denominator times this one, so x minus 3 times x plus 5 times 6 divided by x minus 3, equal. Now I'm running out of room here, so I'm going to go ahead and reduce these factors. So x plus 5 divides at x plus 5, you'll end up with factors of 1s. So I get 4 times x minus 3. So x minus 3 times 1 is x minus 3, right? So 4 times x minus 3. Okay, now remember what I did here was reduce. So I'm going to go ahead and reduce these on this side now. So the x minus 3's divide out. Remember, factors of 1, make sure you put that. X plus 5's divide out. Okay? X minus 3's divide out here. All right, so now notice, remember, the whole purpose of multiplying both sides by the least common denominator is to get factors of 1s in those denominators. See, 1 times 1, 1, and 1. Same reason for this one. 1, 1, 1. So that way our next step, when you look at the next step, you won't have any fractions. All right, so I have 1 times 1 is 1. And so 1 times 3x minus 2 is just 3x minus 2, right? Okay, now over here, be careful. I have memory subtraction. So that's the first thing you need to be aware of. Hey, I'm subtracting, so I need to be more careful because if this was addition here, most students find that if that's an addition problem right here, it's not as difficult as if it were subtraction, but it is a subtraction, so be careful. So I have 1, just forget about the subtraction right now. I have 1 times x plus 5 times 6, right? That's a 6 right here. 6 divided by 1 is 6. Multiplication is commutative. The order in which you multiply does not matter. So I have 3 factors that are being multiplied together. 1, x plus 5, and 6. The way you want to do this is you want to multiply those numerical parts first, the numerical factors. 1 times 6 is 6, so you're going to say 6 times x plus 5. So now you're going to say minus 6 times x plus 5. So you see that subtraction right here. Make sure you bring that down. Equal, and over here we have 4 times x minus 3. And so now notice I went from a rational equation to an equation without any fractions. And in fact, this equation here is now linear. So I went from a rational equation to a linear equation. And now I'm going to go ahead and distribute. So I'm going to distribute the negative 6 here and distribute the 4 here. So I get 3x minus 2. And then negative 6 times x is a negative 6x. A negative 6 times 5 is a negative 30 equal. And then 4x. And then 4 times a negative 3 is a negative 12. Combining like terms, 3x and a negative 6x is a negative 3x. A negative 2 and a negative 30 is a negative 32 equal 4x minus 12. Alright, so to solve this linear equation, I have variables on both sides, variable terms on both sides, constant terms on both sides. So I'm just going to go ahead and bring the variable terms to the left. So I'm going to subtract 4x on both sides. So remember, what you do to one side, you must do to the other. Notice I'm aligning my like terms. Now combining those like terms, a negative 3x and a negative 4x is a negative 7x. Minus 32 equal, this is 0, and 0 and negative 12 is a negative 12. Adding 32 to both sides, what you do to one side, you do to the other for it to be mathematically correct. Combining like terms, these are opposites, I get 0, and so I get negative 7x equal, negative 12 and 32 is 20. And then to get x by itself, let me go ahead and rewrite this over. So to get x by itself, we're now multiplying x by negative 7. The opposite of multiplication is division. So I'm going to divide both sides by negative 7. Divide by the coefficient. Negative 7 divided by negative 7 is 1. 1 times x is x equal negative 27. And that's reduced. Now if you want to write as a mixed number, you would say negative 2 and, let's see, that's 14. So 6/7. Oops, sorry. 14, that's, yeah, 6/7, right? Okay, so negative 2 and 6/7. All right, so that is the solution to that problem. And notice that this is not a restriction. All right, so always verify it's not a restriction. 3 and negative 5 are restrictions. This is not 3 nor negative 5, so there's your solution. All right, let's look at number 4. Now, number 4, this polynomial equation, number 4, is 6x squared plus 7x minus 3 equals 0. All right, so I have this polynomial equation, and you want to solve this polynomial equation by factoring. So always follow directions. The direction says use factoring. All right, don't use any other method than what's in the directions. All right, so again, don't use any other method than what's in the directions. So we're going to have to use factoring here. Now, this polynomial equation is a quadratic equation. So notice the largest exponent you see is 2. So that's a quadratic equation. So you want to solve this quadratic equation by factoring. Now, to do that, though, you have to make sure it's in standard form, meaning you have 0 on the other side, and it's in descending order. So notice the exponent 2, exponent 1, and then your constant. So we're going to go ahead and factor this. Don't forget, when you factor, you have to put a 0 here. So each statement you make has to be mathematically correct. I have a fraction, I have an equation, I better still have an equation. All right, so every Every statement you make has to be mathematically correct in order to get all of your points. Okay, a lot of students forget about that equals zero. Well, if you leave that equals zero off, then this equation is this statement here is not an equation. So every statement you make has to be equivalent. So this statement, this equation, is equivalent to this equation. Now, when I factor 6x squared plus 7x minus 3 using reverse FOIL, so just make sure you're practicing with your factoring. And the ones you have in this course, at least for now, are easy factoring. They're not difficult factoring that you may have experienced in the past. So when I factor this, remember reverse fall, so you have some term times some term has to equal 6x squared. So there are two possibilities for two monomials whose product is 6x squared. There's 2x and 3x. So 2x times 3x and 6x times 1x, right? So let's try the 3x and the 2x first. Okay, now this is an easy one because that last term, forget about the subtraction, but 3, this 3 here, is a prime number. So there's only one possibility for factors of 3, and that's 1 and 3. All right, so that means that this term here has to be either 3 or 1. This term here has to be either 3 or 1. Now, we talked about this before, and I want you to remember this. So if I have, let me go ahead and rewrite this over. Okay, so if I put the 3 here, then that means, see this right here? That means I could factor out a 3, right? So I could factor out a 3, which means, see this 3 right here that I factored out? Which means that 3 it has to go into every term that you see here. 3 goes into 6, 3 goes into negative 3, 3 goes into 0, but 3 does not go into 7 evenly. So that means I cannot put a 3 here because the GCF of those 3 terms on this side, the GCF of those 3 terms is 1, not a 3. So when I factor this, then that means that I cannot put a 3 here. I must put the 3 here and then the 1 there. And then the last sign is negative. So that means, if you remember, that means that when I multiply the last terms, this term times this term, I need a negative number. In this case, negative 3. The only way I can get a negative term here, in a product that's negative, is if one's positive and one's negative. And then that's where you would play around. So you put a subtraction here, addition here, see if that works, because you want your middle term to be 7x. And so it looks like let me go ahead and do this. So it looks like, I'm just going to show you. All right. So in other words, if you put, let's say, this as plus and this as minus, let's say, and you do the outer and the inner, the outer is a negative 9x. 3x times negative 3 is negative 9x. The inner is a 1 times 2x is 2x. When I combine the outer and the inner, 2x, this is a 2, 2x and negative 9x is a negative 7x, but that's not what you wanted. You wanted a positive 7x. So what that means then is that all you do is just change those signs. So in other words, it needs to be factored as 3x minus 1 times 2x plus 3. Okay, so this would be 3x minus 1 times 2x plus 3. And again, you can check that. 3x minus 1 times 2x plus 3 by just using the FOIL method. So 3x times 2x is 6x squared. The outer is 3x times 3 is 9x. The inner, negative 1 times 2x is a negative 2x. And the last, negative 1 times 3 is a negative 3. Combining like terms, namely these two, I get 6x squared plus 7x minus 3, which is what you wanted. Okay? All right, so that was the next step. So the next step is to factor. Now, after that, you got to remember I have two factors whose product is 0. That's what that says. This factor times this factor is 0. So that's where we're going to use the zero factor property. So remember, the zero factor property says that if you have two or more factors whose product is 0, then obviously one of those has to be 0. That's the only way you can get a product of 0. So at that point, this is where you set each of those equal to 0. So you're going to say 3x minus 1 equals 0, 2x plus 3 equals 0. So now notice I went from a quadratic equation to two linear equations. And so we're going to solve these linear equations. So we're going to add 1 to both sides. So I get 3x equal 1. And then divide both sides by 3. Reduce. I get x to be 1/3. So there's one of your solutions. Over here, subtract 3 from both sides. I get 2x equal, this is 0 when you combine like terms. 0 and negative 3 is a negative 3. To get x by itself, I'm going to divide both sides by 2. That's your coefficient of x is 2. So remember the opposite of multiplication is division. So divide by 2. And so 2 divided by 2 is 1. 1 times x is x. So I get x equals negative 3/2. All right, so that's number 4. All right, number 5, we have 3 times 4x minus 1 squared plus 2 equal negative 10. So 3 times 4x minus 1 squared plus 2 equals a negative 10. Now, again, make sure you always follow the directions. The directions actually said here, use the square root property. Square root property. And so notice when you're using the square root property, and let me see if I can use a different color here. And let me write it on here as well. So when I use that square root property, oh, and by the way, I want you to notice that this is a quadratic equation. So just like this was a quadratic equation, most students can see very easily this is quadratic because your largest exponent is 2. Some students have a little bit difficulty seeing that this is quadratic. But if you were to square, see how you have this linear expression being squared? So in other words, if you were to just take this part here, 4x minus 1, and multiply it by itself, because that's what that squaring says, and then FOIL, I'm not going to FOIL it all out, but notice I'll get 4x times 4x is 16x squared. So notice when you do this, you're going to get your largest term having an x squared in it. So that's quadratic. But in this case, they wanted you to solve using the square root property. So I want you to also notice that you need to recognize that the easiest way to do this is to use the square root property because you have this part here. You have some expression being squared. So when you have an expression being squared, you're eventually, to get rid of that square, you're eventually going to take the square root of both sides. Remember that? Because the square and the square root undo each other. But to get to that point, you got some things you got to do here. All right, so let's go ahead and do those things to get this by itself. So what you want to do is to isolate 4x minus 1 squared by itself before you take the square root of both sides. So the easy thing to notice here is that, hey, I have this expression right here that has that 4x minus 1 that I'm trying to get by itself, but I'm adding 2 to it. So the opposite is to subtract 2 from both sides. So let's go and do that. So when I subtract 2 from both sides and combine like terms, I get 3 times 4x minus 1 squared equal, and then negative 10 and negative 2 is a negative 12. Now, one thing that some students, if they're not thinking carefully, do make a mistake is this. So let me just kind of remind you. So they want to use a distributive property here. So they in other words, they want to multiply every term inside this parentheses by 3. The only time you can use a distributive property is if that expression here is being raised to the first power. Then you can use a distributive property. You cannot use a distributive property here. So can't use the distributive property. So in other words, you cannot multiply both of these by 3. That's incorrect because you're squaring this. All right? So you have to be careful. So let me just kind of show you this to show you why mathematically that's not correct. Okay, let me just show you real quick. 3 times 4x minus 1 squared, right? So if I write this thing out twice, I get 3 times 4x minus 1 times 4x minus 1, correct? Okay. Now I want you to notice this. Suppose someone made the mistake and distributed first. So they would say um, 3 times 4x is 12x, and then 3 times negative 1 is negative 3, and then squared. So now they would have 12x minus 3 times 12x, that's a 12x, times 12x minus 3 times 12x minus 3. Well, we should notice though that this product, that this part here is not the same as this. Because look, if you distribute here, which you can now because that's a 1, you get 3 times 4x is 12x, 3 times 1 is a negative 3, times 4x minus 1. Notice that these two are not the same. You have 12x minus 3 as a factor, but these factors are different. All right, so that's why you can't distribute this 3 here if this exponent is not a 1. Okay, what you end up with is not correct. All right, so this is a mistake people make sometimes. They're going to want to distribute first. You cannot do that because that exponent is not a 1. Okay? All right, so be careful. So the next thing you want to do, though, instead of distributing, which you know is not correct anymore, you have this expression that's being multiplied by 3. So the opposite is to divide by 3. That's your next step. And so 3 divided by 3 is 1. Make sure you put factors of 1 here. So you get 1 times 4x minus 1 squared is 4x minus 1 squared equal, and then a negative 12 divided by 3 is a negative 4. And now what you want to do, I'm going to write this over. So now we have, so whenever you use the square root property, you're going to take the square root of both sides whenever you have something that looks like this, where you have some expression squared equal a number. And that's what I have here. Some expression squared equals a number. So now I can take the square root of both sides. But remember, when you take the square root of both sides, you get plus or minus. So don't forget that plus or minus there. So let me go ahead and do that now. So I'm going to take the square root of both sides, just like this, plus or minus. And so the square and the square root undo each other. They're inverses of each other. So you get this expression here, 4x minus 1, equal plus or minus. Now you got to remember, you have to remember this, the square root of a negative 4. We all know that the square root of a negative 1 is defined to be I, that imaginary unit I. So the square root of a negative 4 is square root of negative 1 times square root of 4, right? So that's I times 4. Oh, I'm sorry. I times, and then square root of 4 is 2. But remember, we write this better, so write it as 2i. So the square root of a negative 4 is 2i. So that becomes plus or minus 2i. All right, so now I have this. So my solutions are going to be imaginary solutions. And so to get x by itself, since this is an imaginary part here, I'm just going to go and write it in compact form. So in other words, the best way to do it is just to say plus 1, just like that. And they combine like terms. Negative 1 and 1 is 0. So you get 4x equal 1, positive 1, plus or minus 2i. Make sure you understand that this right here means 1 plus or minus 2i. That's what you see. Now we're going to divide to get x by itself. Let me go ahead and put that here. So to get x by itself, that's an I here. Make sure, now again, I'm using a pen, but you can still use liquid paper if you do make a mistake here. Just make sure that this looks like an I. So now we're going to divide both sides by 4. So I get 4 divided by 4 is 1. 1 times x is x. I get x equal 1 plus or minus 2i divided by 4. So that's your solution. So remember, there are two solutions. See that plus or minus? Some students, though, prefer to write them separately. So you'll say 1 plus 2i divided by 4, comma, and then 1 minus 2i divided by 4. So those are your solutions. Okay? All right. Now, let me just kind of show you this. So where we had this right here, 4x minus 1 equals plus or minus 2i. So you have this expression equals to two things. Oh, that's an I here. Equal to two things, a positive 2i and a negative 2i, right? So at this point, instead of writing them in compact form like I did here, You could separate them. You would say 4x minus 1 equals 2i, and then 4x minus 1 equals a negative 2i, right? And then you solve for x. So we're going to add 1 to both sides. So combine like terms. I get 4x equals 1 plus 2i. That's a positive right here. 1 plus 2i. Make sure you understand that's what you write. Don't say that's 3i because that's not an I here. That's a 1. Those are not like terms. This term has an I. This term does not. So those are two different terms. And then divide both sides by 4. I get x equal 1 plus, 1 plus 2i divided by 4, which is what you see here. And then the next one, add 1 to both sides. We get 4x equal, this is 0, 1 minus 2i, and then divide both sides by 4. The 4's divide out. You get 1 times x is x equal 1 minus 2i divided by 4. Okay? Which is just right here. So again, it doesn't matter at this point whether you write it in compact form, just like this, or if you want to, you can separate them and do this. It does not matter. All right. So that was number 5. So let's look at number 6. So in number 6, you have 4x squared minus 8x minus 1 equal 0. So 4x squared minus 8x minus 1 equal 0. Now the direction says use the quadratic formula. So always follow directions. Use the quadratic formula. So remember the quadratic formula when solving a quadratic equation is this. So you get x equal, if x is a variable, you get x equal the opposite of b plus or minus the square root of b squared minus 4ac. And remember b squared minus 4ac is called the discriminant, divided by 2 times a. So there's the quadratic formula. And so basically all you're going to do is first of all make sure this is in standard form, which it is. You have 0 on the other side, and it is in descending order. So this is already in standard form. Once it's in standard form, it's a good idea to denote what a, b, and c are, right? So those are the numbers you're going to substitute into here. So that's equal right here. So a, remember, is a coefficient of x squared. So remember the coefficient of x squared once it's in standard form. So make sure there's a 0 on that side. So a is a coefficient of x squared, which is 4. So put 4 here. B is a coefficient of x, which is a negative 8, not 8, a negative 8. So you have to be careful with your signs. And c is your constant, which is a negative 1. So that's c. All right, so I'm going to take those numbers. I'm going to substitute into the formula. So I get x equal. So this says I take the opposite of b. Well, b is a negative 8. The opposite of a negative 8 is a positive 8. Plus or minus the square root of b, which is a negative 8. Put that in parentheses. And then you're squaring that. So remember, b squared is never going to be negative. So be careful. If you did not put negative 8 in parentheses and use your calculator, that would give you negative 64, which is not true. It's a positive 64. Minus 4 times a times c, all divided by, remember we talked about extending it. Make sure all of this is above this division symbol right here. All right, so you don't lose any points. Divided by 2 times a, and a is 4. All right, and then let's go ahead and simplify the discriminant. In this case, remember the part that's under the radical is called the radicand, but in the quadratic formula, it's also called the discriminant. All right, so I have negative 8 squared. I'm going to put this on the side, which is 64. Okay, and then I have a negative 4 times 4, which is a negative 16, and a negative 16 times a negative 1 is a positive 16, right? So 64 plus 16. 64 plus 16 is, what's that, 80? All right, so I get 80. So this becomes 8 plus or minus the square root of 80 divided by, and then 2 times 4 is 8. Now, you always have to ask yourself, can I simplify the square root of 80, right? Can I simplify the square root of 80? So you need to look at perfect squares that go into 80. So just take your calculator out and just see, and always use the largest perfect square. Now, 1's a perfect square, so 1 will always go into this discriminant. But let's go ahead and use and use a calculator. Let me go ahead and get the glare out of the way. So let's try 80 divided by, remember 4 is a perfect square, right? All right, so 4 goes into 80, but I want you to notice that 20. What other perfect square other than 1 goes into 20? 4 goes into 20, doesn't it? So I have this 4 and then this 4 as a factor, so that's 16. So what that means is this. 80 divided by 16 is 5. So 16 is the largest perfect square that goes into 80. So in other words, the square root of 80 will be the square root of 16 times the square root of 5, right? And then the square root of 6, because 16 times 5 is 80. And the square root of 16 is 4, so I get 4 square root of 5. And that's what's going to go here. So I get 8 plus or minus 4 square root of 5 divided by 8. All right, now we talked about many things in the videos and the lessons and in class. If this is face-to-face, we talked about many things. One thing we talked about is that some students, when they see those 8s right here, when they see the 8s that look like this, one in the numerator, one in the denominator, the first thing they want to do is this. They want to reduce those 8s. You cannot do that. You cannot do that. This is wrong, right? That's wrong because both of those terms that's in the numerator have to be divided by 8. So if you do this, then this is no longer being divided by 8. So you got to be careful. All right, so you cannot, mathematically that's incorrect. So what you need to do is notice this. 8, I'm going to go ahead and rewrite this over. I want you to notice that this term, and this term. Notice the 8 here, that 4 here, and that 8 are all divisible by 4. The largest factor is 4. Now, they're all divisible by 2, obviously, but always use the largest because you want to reduce as much as possible. So they're all divisible by 4. So in other words, I'm going to get 8 divided by 4 is 2, plus or minus 4 divided by 4 is 1. 1 times the square root of 5, divided by, and then 8 divided by 4 is 2. Now, so I get this. Now, again, don't make the mistake and divide those 2's out because that's incorrect. So I want you to notice, again, 2 plus or minus the square root of 5 divided by 2. If you do, I'm going to put the word wrong so y'all can see that word here, wrong. You cannot do this. So don't say the answer is 1 plus or minus the square root of 5. That is not true. Okay? What is true, though, is this. So you see I have this. Now, if someone wanted to do this, now I would leave the answer like this, by the way. So this is the answer. But what I want to mention is if someone wants to go further and say this, 2 divided, so all these divided by the denominator, 2 divided by 2 plus or minus the square root of 5 divided by 2. And now you can reduce this. 2 divided by 2 is 1. You get 1 plus or minus the square root of 5 divided by 2. Now that is true. So notice that this right here is not the same as this, right? Okay. So you got to be careful with how you reduce with something that looks like this. Okay. All right. So that was number 6. So number 6, you have to use the quadratic formula. All right, and then finally number 7. So let's get number 7. So in number 7, we have 2x cubed plus 2x cubed. Oops, let me write it better. 2x cubed plus 5x squared minus 6x minus 15 equals 0. All right, now you have this polynomial equation, and the direction says you're going to solve this by factoring. So solve by factoring. So I'm giving you a hint here. So the hint is to solve by factoring, right? So I'm giving you a hint. Now, one of the things you learned in the past, I'm going to go ahead and cover this part up, was that when you factor, and I'm going to go ahead and write it here. When you factored 2x cubed plus 5x squared minus 6x minus 15, remember when you factored a polynomial that had 4 terms like this, you wanted to try factoring by grouping, right? So grouping. So basically, and what normally worked, not always true, but what normally worked was you group the first 2 terms and group the last 2 terms. And so when I grouped, I'm going to go ahead and put the work here. So 2x cubed plus 5x squared minus 6x minus 15. So now group the first 2 and group the last 2. In that first group, I'm going to cover up this part here. In that first group, the GCF is x squared. Okay, that's your GCF. So I'm going to factor out an x squared from that first group. When I factor out an x squared from the first group, I get x squared times 2x is 2x cubed plus, and then x squared times 5 is 5x squared. So this right here can be written as this. So I factored out the GCF, which is x squared. So that's your GCF of that first group. In the second group here, this one here, minus 6x minus 15, you always want to factor out. See how that sign right here is negative? You always want to factor out that middle sign. So if this was plus, you put plus. If this is subtract, you put subtract. And then the GCF of negative 6x and negative 15 is a negative 3. And so when I factor out that negative 3, I get negative 3 times 2x, and always verify. Negative 3 times 2x is a negative 6x, and then negative 3 times a positive 5 is a negative 15. If you're doing this correctly, those two expressions you have in parentheses better be the same. So notice they're the same. All right, so now what you want to do is you want to see this part here and this part here, those two expressions, they had that 2x plus 5 in common. So now you're going to factor out that 2x plus 5. So when you factor it out, you get 2x plus 5 times. Now when I factor out that 2x plus 5 here, I'm left with x squared. See this? X squared. So you get times x squared. And it can always verify, look, 2x plus 5 times x squared is this, isn't it? And then factor out the 2x plus 5 here, you're left with minus 3. And always verify. So if I would distribute this back, 2x plus 5 times x squared is this, and then 2x plus 5 times a negative 3 is this. And so this right here, which is this right here. So you have to show that this, you have to write this now. You have to say 2x plus 5 times x squared minus 3. Again, equation, right? Equals 0, so you must say equals 0 for it to be mathematically correct. So don't lose any points just because you left the equals 0 off. And now we have two factors whose product is 0. So that's that zero factor property. So I'm going to take each of those factors and set them equal to 0. So each of those, set them equal to 0. And I want you to notice, though, I went from this cubic, remember the largest exponent is 3, so cubic equation, to a linear equation and a quadratic equation right here. That's quadratic. And so all of us know how to solve this linear equation. So we're going to subtract 5 from both sides. So I get 2x equals negative 5. And then we're going to divide both sides by 2. So my solution is going to be negative 5 halves. Well, I want you to notice here, though, the best way to solve this quadratic equation is to, first of all, notice that there is no x term. I have an x squared and a constant. There is no x term. So since there is no x term, you want to use the square root property. So you got to get that x squared by itself. So in other words, I'm going to add 3 to both sides. And so I get x squared equals 3. And now I can get x by itself. I can get x by itself by taking the square root of both sides. Don't forget your plus or minus. So the square and the square root undo each other. So I get x equals plus or minus the square root of 3. And I cannot simplify the square root of 3 any further. Cannot simplify the square root of 3 any further. So those are your three solutions. So you can leave it like this, or you can write it as x equals negative 5 halves, positive square root of 3, and a negative square root of 3. Okay? All right, so that is, I believe, that is the study guide for the problems dealing with solving polynomial equations and rational equations.